Stick around if you want to learn how to create layered compound walls in Revit 2021. Welcome to another tutorial. I'm the Revit Man, and in this video I'm going to show you how to create compound walls in Revit that consist of multiple layers, multiple materials, as well as a few tips along the way that'll help you create better wall assemblies. Before we get started, make sure you take a second to click that subscribe button so that you get notified when I upload new videos. Alright, let's dive into Revit. So we're going to start by selecting the wall tool. So we're going to click the wall tool, or you can type in WA for the keyboard shortcut for walls. And then we're going to go over here to the properties palette and we're going to click edit type. And because Revit walls are considered a system family, you cannot just go and create a new one. You actually have to duplicate an existing type. So we're going to duplicate this one. And then you're going to go ahead and enter in a name for the wall. So now for this tutorial, I'm just going to type in like tutorial wall. But in reality, you're probably going to be a lot more descriptive about what that wall is. So the best practice would be more along the lines of this format. It would be type, if it has one, so interior wall, exterior, foundation, some sort of descriptor of how that wall is used. The name of, if it has one. So the company I work for, a lot of times we call it like wall assembly 1 or wall assembly 2. And then it would be the structural layer, so CMU, metal stud, wood stud, or anything else. And then the finish layer. So a description what the finish layer would be. So brick, siding, stucco, that sort of descriptor. And then you can add other information as well, like thickness or something of that sort, to provide more information so that it makes it easier for other users to then go and select the right wall type, or even for yourself if you're coming back to the project at a later date. So then next we're going to go here and we're going to click this edit structure, and then this will bring up the edit assemblies window. Now there's a couple things here that I want to point out before we actually create some additional layers for the wall. The first is this area right here, which it's going to give you the family name, the type of wall, so this will be just what you just entered in, and then total thickness. So this will give you an idea of, as you're creating the wall, how thick that wall assembly actually is. And then if you don't see this little preview window over here on the left hand side of this window, you can go down and select this preview button, and that'll pop up this preview window. So then you can kind of see your wall assembly then as you create it. Also take note here that right here it'll say exterior side of the wall, and down here it says interior side. So this helps you orient as you're creating your walls, what side's going to be considered the interior, what side's going to be considered the exterior of the wall, so that you're placing your layers in the right location. Okay, so for this tutorial we are actually going to be creating what's called the perfect wall, and that's defined by the Building Science Institute. And basically this is a wood framed wall that one would typically see in like a northern climate. So I'm in Wisconsin, so this is a wall that I use all the time. So then take a look here at the core boundary. So basically this is setting up your core or your structural layer of your wall. So now the wall we duplicated only had a single layer, so it was only the structure of the wall. So in our case with the perfect wall assembly here, our core or our structure is the wood framed wall. Now with wood framed walls, or walls that consist of this layer that consists of multiple parts, like in this case we have an insulation and the wood framing. There's a number of different ways that the industry will tell you what the best practice is for modeling this. Now you could just go and call it a wood layer, but you know it's not solid. You could go and call it an insulation layer, but then you don't really want the structural properties of insulation. You want the structural properties of wood. So I'm going to show you the way I typically do it, which is kind of a mix of both. So since this is the structure of the wall, we're going to keep this function as structure, and now we're going to go here and change the material to a wood material. So you're going to see here that I have softwood lumber right here. If you don't have it and you want to find it, you can just type in wood into the search bar and you'll see here. So most wood framing elements that the typical product is pine, larch, fir, more of a soft wood, soft species of wood. So I'm going to use softwood lumber then as the basis for my wood wall. Now we're going to have insulation. So what I'm going to do is I'm actually going to duplicate this so that it's something different, so that if there are any other materials in the elements in the project that actually have softwood lumber then as a material, I'm not overwriting those. So I always duplicate the material when you're trying to change it. So I'm going to just call it softwood lumber with insulation, and everything else is going to stay the same, but you can go in and then later, at a later date, you can go and change the thermal properties of that material if you're doing energy analysis or anything of that sort. And then I'm just going to, now that I've created it, I'm just going to go here and click OK, and you'll see softwood lumber with insulation. And now I'm going to change the thickness. So in our case, it's a nominal 2x6 stud framing, so that's actually 5.5 inches. Alright, so now we're going to move towards the interior side of the wall first. The first layer that we are actually going to create then is the vapor retarder layer. So in northern climates like this, it is common practice to have a vapor retarder between the studs and the drywall, and this is typically a 6 mil polyethylene plastic sheet, or 6 mil poly if you're familiar with that term. To create this, we're going to actually go to Insert, and that'll create a new layer, and then you can use these up or down buttons then to put it where you want it within the wall assembly. Now, it said it was a membrane layer, so we're going to go and change the function then down to membrane, and then we're going to go here and type in vapor. So we're going to pick the vapor retarder so that we actually assign appropriate material and appropriate characteristics to what that membrane layer is. Now, Revit doesn't allow you to actually put in a thickness for a membrane layer. Clearly, a 6 mil poly would have a 6 mil thickness to it. But for the sake of Revit, it does not allow you to actually put in a thickness. Now, I'm not going to really cover the wrapping or structural materials in this tutorial, but we'll just leave these checked for now for this tutorial. Alright, so now we're going to go and insert the drywall layer. So we're going to insert, move it into place, and then this is your interior finish. So I'm going to use finish 2. Typically, the best practice for when creating walls, exterior finish, we're going to use finish 1. Interior wall, you're going to use finish 2. There are some circumstances where you might need to change that a little bit, and that's okay. But for the most part, finish 2 is your interior. So I'm going to go here, and it is gypsum. So I'm going to gypsum wallboard, and click OK. Now this is typically a 1/2 inch of thickness, and you'll see now over here in the preview window that it added that 1/2 inch layer of drywall to our interior face of the wall. So keep an eye on that preview screen then as we build more layers to this wall. So that covers the interior side of it. Now we're going to move to the exterior side. So go ahead and insert a new layer. And this is going to be the structural sheathing level layer. So we're going to change this to substrate. So this is the substrate where everything else gets attached on the exterior side. So it's often called the substrate. And then we're going to change the material then to, in most cases for this type of wall, it's going to be a plywood or an OSB oriented strand board product. So we're going to click OK. And the thickness here is 1/2 inch. You'll see again in the preview window that it added that layer to the exterior side of the wall. The next layer then that we're going to add is the weather resistive barrier, or WRB. So in typical wall construction, your standard stuff, it's going to be more of a sheet applied weather resistive barrier, something in the line of Tyvek or a similar product. So we're going to go ahead and insert then, and luckily this one already is in the actual location. We're going to choose another membrane layer, and I already know that Revit does not have a weather resistive barrier, but they do have an air infiltration barrier. So what we're going to do is we are going to duplicate that one and just call it our WRB. Alright, and then we're going to select that material and place it here. It's going to be similar characteristics to what your air infiltration barrier is. You just want to make sure that the material that you're applying has a name that makes sense for what it actually is, so that when other people come in and use your model, that they know what that actually is, and that they're not putting in an incorrect material or an incorrect object just because you named it something convenient or something like that. Happens to everybody. Just get in the habit of duplicating and naming things appropriately. And now we are going to then insert the next layer. So typically, if you look at our perfect wall assembly, the next layer then is this continuous insulation on the exterior side. Now this is something that is typically code mandated for some of the northern climate zones, that there's a continuous insulation layer on the exterior of the building. So we're going to go ahead and create that now. So insert, now we're going to change that to the thermal air layer, and then material. So you can see, like, I typed in rigid insulation. That's typically what it is. So that's more of a generic. So if you don't know what type of insulation you're going to use yet, you can go ahead and just type in rigid insulation or insulation. But if you look down here, down in the asset browser, you can see that there's actually different types of insulation. There's polyurethane, there's polyisocyanurate, semi-rigid. They also have like rock wool, I think expanded and extruded polystyrene or show up in that list as well. So you can actually pick which type of insulation you want further down the road, but for the case of this tutorial, I'm just going to use rigid insulation. You can kind of see some of the graphics that it shows up. Like, this is the color it's going to come up as, this is the hatch pattern that's going to show up. And you can go and adjust all that as you need to get the correct graphic representation that you're looking for. And all this can be changed at a later date. If you just want to go and assign the materials now, that's totally fine. All right. And for this wall, we are going to do a 2-inch thickness of it. So you can see that a 2-inch layer then of rigid insulation added to the wall in the preview window. Alright, so now if we look again at that perfect wall assembly, you'll notice that there's another layer, a rain screen wood furring layer. So it is best practice in the industry when installing over rigid insulation to have a rain screen application. And you do this for a couple of reasons. One is to allow a path for water to run down the face of that insulation on the inside of that wall cavity. And two, it also allows for drying. It allows air to circulate then through that wall assembly and dry any of the water that did get in there. So it's one way to help manage moisture content in your wall assembly. So like I said, it is the best practice in the industry, and the way it's created here is it's going to be similar to the conversation that I had with you about the wood stud with insulation layer. The bulk of this layer is air, but there is wood framing in it. So you can play around with how you handle modeling that one. But for this tutorial, and the way I typically do it, is I model it as an air layer, and then in my details or in something else, I will go and show the furring in those locations and not actually in the actual wall assembly. So again, I'm going to choose another thermal air layer, and you can actually go and just type in air in the search bar here to get the air material. Now it's good to assign the air layer material because air does have thermal properties. So if you are running a thermal or a energy analysis of this building, air does play a role in the thermal performance of that wall assembly. So the furring in our image is actually a 1x4, so that is actually a 3/4 inch furring strip. And now we can go into our last layer then, which would be our siding material. So for this one, I'm going to do finish 1. And then the material that we're going to choose then is, if I just type in siding. Now this can be anything. It could be siding, it could be brick, it could be stone, stucco, whatever your finish layer actually is. And Revit has a good amount of materials already created, but you can always create your own materials. So we're going to use siding clapboard. which is your typical lap siding. And I'm just going to call it a 1/4 inch. Now I don't know what the actual thickness of it is here, but for the sake of the tutorial, 1/4 inch. Now you notice that as we added layers, this total thickness parameter changed. The wall is now 9.5 inches thick, and you've created a layered wall assembly with different materials. Okay, so there's one major thing that I want to point out to you guys about this layer structure, and that's these numbers that are in the brackets after each function layer. Now, in Revit, there are several purposes for these numbers. The first is in this dialog. You'll notice that it goes from structure 1 at the center of the wall, and it increases in value to the interior side or to the exterior side of the wall. So these numbers help to organize the layers within a wall assembly. So you'll notice, like, if I change this air layer to substrate and then click OK, Revit gives you an error message. It does not let you create a wall where the layers are out of order. You can have multiple layers of the same number or of the same type, but you cannot alternate or insert a lower number between two larger numbers. The second function of these numbers is to establish join priority. Now, what join priority is when two walls come together, the different layers extend and join in different ways depending on what layer they are and what material they are. So these numbers help in Revit determine what the appropriate join order is for the different layers and materials. So we're just going to go ahead and click OK, and then you want to click OK again in this type properties dialog, and now we can go ahead and draw our wall. So this will happen a lot. So if you ever draw your wall and you're like, what happened to my layers? Most likely it's because you're in a coarse view. So if you go down here to the view properties for this view, there's this rectangle, that's your detail level. You want to set that to fine, and then you'll see the layers. Now, if this looks kind of chunky and you're like, this doesn't look right either, up here in the quick access toolbar there's this thin lines, or you can use TL is the keyboard shortcut for it. If you click that, now you can it gets rid of the line weights in this current view. They're still there when you go and print and stuff like that, just how you view it. Now you can see all your layers. Alright, so that wraps up this tutorial on layered compound walls. If you enjoyed the tutorial, make sure you give it a thumbs up. Subscribe to the channel for more videos just like this one. And if you have any comments or questions about any of the content I covered in this video, please make sure you leave that in the comments section below. And if you want to see the next video in this series, make sure you click that Revit Walls playlist, and thanks for watching.